So thank you for coming back. And we're going to work on an example where you get to use FakeNet yourself. Hopefully you've had a chance to copy the VM off. If not, there are USB sticks going around. If you left earlier with the USB stick and you came back with it now, please pass that off to somebody else to copy it or return it to us up front. Yeah, the way it works is we saw FakeNet. It's pretty easy. You just double-click to run it, right? And that's on the desktop. But if we want to change the settings, we have to go to C, Tools, FakeNet 2. So a lot of the lab is talking about changing the settings. So you're going to have to go into there and open up this fakenet.cfg file. You can open it up in Notepad, and you can manipulate it there. If you notice, the lab is in Z malware, and then the lab is lab_evil. Also, there's a text document there, lab.txt, that's going to contain like the questions for the lab. So you open that up. We could take a quick peek at that. So it's one after another sort of steps that take you through how to analyze it. So, first is let's just run the malware with FakeNet on. So start like that, right? After that, it's, what do you see the malware download? What web pages does it go to? Then maybe try and turn on this NX domains option to see if you can tease out additional domains. So basically, just try and figure out as many domains, as many connections as you can get it to go. After that, we're going to turn on process logging, which means you go into the configuration file and turn that on by setting the process logging to yes. After the process logging, then you'll be able to identify which process is actually doing the malicious activity. And being that we're asking it, you could bet that lab_evil.exe is not the process that's doing the network connectivity, right? That wouldn't make the example very cool. So turn on process logging and then figure out what process is actually doing the connection. After you've done that, you move to, now you want to set the breakpoint like we were demonstrating. So you use that connection break functionality. That is inside of connection break. This change that option from no to yes. Also, make sure you turn on Ollie debug as your just-in-time debugger. So you go to Options, Just-in-Time Debugging, make Ollie debug my just-in-time debugger, and then done. And you could close out. Once you've done that and set this to yes, any process that starts up and makes a network connection is going to break in your debugger. So what we want to do there is reconfigure that, restart FakeNet, and then run your malware. Hopefully it'll break, and then you're going to track down. Maybe there's other domains that the malware might connect to that you wouldn't have seen unless you use this debugging breakpoint. And then after that, it's figuring out the puzzle is the final step. To figure out how to get, what can you have FakeNet serve the malware, right? Because in FakeNet, we can have it serve the malware anything it's asking for, right? If malware is doing a GET request for a web page, we could serve it whatever web page we want. We just go into C, Tools, FakeNet, and then the default files. In here is just a bunch of files that are served up. For example, Andy showed earlier the FakeNet mini program. When you run that, it just does a pop-up. But we could change that. We could put any executable, any file we want in there, and that's what FakeNet will serve up instead, right? So the final step is, what can you have FakeNet serve up the malware such that it gets the malware to open a message box? Basically says like you win or something like that. So that's the goal of the lab. You go through all those different steps. So it's exercising each of the functionality of FakeNet and getting familiar with it. If you sort of get stuck on that, we're here to help you. Also, if you want to start running other files inside of Z malware, there were the files I ran in class, which was webserver.exe, if you wanted to try that again, or demo.exe. And you remember demo.exe is the one that injected into calc, so we were able to see that. Also, the labs from the book are here, so you can run any of the 50 binaries from the book, so that way you can tease out network functionality using FakeNet as well. So there's a pile of binaries you could play around with, but the major focus is to get through this, figure out what the key is. So I guess, do you guys have any questions on FakeNet, life, anything like that? We have all the answers. And so, yeah. So with that, I guess the goal is I think we have an hour, right, until 3:15. So we're going to give you like 30 minutes right now to work on this, and then we'll go over it and show you how to get the answer. So go for it. Oh, yeah, and yeah, I mean, the NX domains option, I don't know if we talked about it too much, but it's basically the way to, sometimes malware, like if you return a valid domain name to a piece of malware right away, then you're not going to tease out the additional domain names from a piece of malware, right? Right, there might be like 10 other embedded domain names, and we want it to siphon through all those domain names. That's where the NX domain option comes in. You could set that to something greater than 0 inside of FakeNet, and that'll return a non-existent domain for each of the requests. Right, so like let's say he requests a.com and then b.com, and then that is only 2. If you do an NX domain 1, like set it to 1, the next time it requests a.com, it'll actually return valid. So this is a way to tease out additional domains.
Because they always have a backup domains for that.
Yeah.
To connect. So
right.
But we have a bug in the lab, so it's going to see what.
Yeah, so the NX domains may or may not be useful, in other words. So. All right. So let's go over this then. Start by running FakeNet, and let's take a look at what happens when we run the evil binary. Nothing, apparently. I don't know why it broke there. Let me try and run it again. Oh, I must not have networking set up, which is weird because I went to the clean snapshot, which should have it. Huh. It's a little odd. Maybe FakeNet wasn't done closing out. Okay. So we ran it, and it says, well, it looks like we have a user agent of surfs up, and it looks like it goes to bb.exe, bb.practicalmalwareanalysis.com. It does a request for test.jpg. Also looks like maybe it goes to hello.malwareanalysisbook.com. So those are the couple domains that we were able to see so far. Also, if we turn on NX domains, we'll see that we really only get those 2 domains. So the next, unless you got lucky. If you got lucky, you maybe saw another domain, because there is a randomness factor with what the other domains that it hits. So the next step was to turn on process logging. So we could go into Tools, FakeNet, Configuration, turn on the process logging, which will be on by default in the future, but the point is to learn. Run it, and we run the malware. And this time we see that, hey, notepad.exe is connecting over port 80. So we now know that the process that's been injected to is notepad.exe. Now we want to do the connection break functionality to pinpoint the code that's doing the connecting. So we're going to turn on, inside of FakeNet, we'll turn on connection break. We will turn on our just-in-time debugging. And then now we have just-in-time debugging open. So we should break when we run the malware this time. And we were able to break. We're in the exception handler, so we're going to step out of it. And then we're going to do what we did earlier, which was, hey, we took a look at the stack trace. There wasn't really much to be had there. It didn't get us back to the original place where it's coming from, because obviously our code's not all coming from WinINet. So we think there might be shell code. So what we could do is set our break on access on the RWE section, which is the section with the shell code. Hit play, and it breaks on access when it gets back to that shell code, which tells us that, hey, this previous call was the one that actually ended up doing the connect. It was a higher level call to some WinINet function, but we don't know which one. That's fine. But let's poke around and see, if there's anything here to be found. Like earlier, we were looking on the stack in the demo example, and look, there appears to be some strings on the stack here. So we turn this into some ASCII to look at, and we start to see test.jpg makes sense to us. Super evil.txt, we haven't seen that yet. So that's a new string that we've now found. Also, we see bb.practicalmalwareanalysis.com, which was one of the places it went. Also, we see the other one, which is hello.malware.book.com. We see that as well, but now we see two new domains. And the new domains one is the password is.com, and the other is orvalandrochefort.com /superevil.txt. So right away we could start thinking that, hey, maybe there's a couple extra domains in there that happen with some frequency, right? Maybe it's going to go to those domains in some other occasion. But we were able to see those by having a breakpoint here and be able to go directly to that spot. Also, we see this "you found me" exclamation point string. So we don't know what that is used for, but that's probably getting that message box to pop up like we were talking about. So the next step requires you to be a reverse engineer, obviously, because you have to figure out how you can get it, like what has to occur to get that message box to pop up. So you have to perform some code analysis here. And so if you analyze this shellcode at all, the best thing to do would be to rip it out, pull it into something like IDA, and we have the freeware loaded on this VM. It's a good place to start. Or you could just look at an ollie and reverse it that way. Also, this is in a loop. If you remember, it was in a loop going to different domains, right? Like it would do 4 or 5 of them in a row, and then before exiting. So maybe this is going to loop up. So I could probably step through this a little bit and see if that happens. So that's the internet read file. That's where it's getting something from the system, and it's jumping around. So it's going up in some loop. We know it's going to loop through this again. Now it's calling get tick count, and then doing some type of mathematical equation on it before deciding to jump here or not. And if I take a look, and while analyzing this code, I'd realize that if this jump is taken, that's going to take me to where it's been before. So we don't want this jump to be taken. So we want to do something like flip the 0 flag, so that way it's not taken. And then we see a series of calls here. So we could step through those. See internet open with surfs up. Makes sense. That's what we've been seeing so far. We see internet open URL. However, this time it's different. Right? If we take a look, now it's orvalandrochefort.com /superevil.txt. So maybe what we have to serve up via the superevil is the thing we should go after. Next, we scroll down through the code a little bit, because we know that after it does an internet open URL, it's going to do an internet read file. And we saw that happen earlier at this location. And what gets returned to internet read file is a buffer, right? So maybe it's comparing something to that buffer. And we see 2 comparisons here, 1 to 34 and 1 to 32. And what is 34 and 32 in ASCII? 34 and 32. or hex 34 and hex 32, I should say. 42, right? So I kind of gave the hint a little bit earlier in the class, right, as to what the code was. So it looks like it checks the first 2 bytes of superevil.txt for having the 42 as the string. And if it does, looks like it's going to come down here and do this call. So we could kind of step through this a little bit. Oh, I just think I stepped over it. Oh, no, it's actually in our breakpoint, which is pretty funny. Of course, because it's doing a connect. So we see the internet read file. Of course, it's not going to be fed the 42, so we're going to have to kind of trick it here. So right here, it's going to say jump is taken. We don't want that to happen, right? Because that's the comparison to the 4. Then there's a comparison to the 2. We don't want that to happen either. Where am I? Jump is taken. Oh, no, sorry. Set. And then it comes down here. So we basically forced it to go through. And now we see that it's about to call a message box. If we step over that, we'll see, hopefully our message box came up, you found me. And so that's the key. So it does require some analysis, but here you see how FakeNet caught that entire transaction that I just stepped through, which was, went to the Orval and Rochefort.com, and which I know many of you found. But then the trick is what do we serve up as super evil? So what we could do is to force FakeNet to serve that up. We could go into the FakeNet tools, FakeNet 2 default files, and put in, if it's going to get superevil.txt, we could put a different text file in there, right? One that any file that starts with 42 will do it. And by default, if FakeNet will serve up an HTML page, so we could just change this HTML page to start with 42, and that's good enough to get it to pop. Of course, it has to actually go to that domain, which is something we forced to happen. And the way the shellcode works is actually every 1 out of 1,000 chance it'll actually go there, versus the other 2 domains were like 50% chance. So possible for malware to do this exactly? No, but is it realistic that malware might go to a bunch of domains before actually going to the real one? Oh yeah, that definitely happens all the time, right? They're trying to test and see if that connection is available. I've seen a piece of malware that goes to google.com every day for a week, and then on day 8 is when it actually goes to the bad place. So, I mean, it is a realistic scenario. So I think that's, did you have anything else to add to lab? Okay, so if you guys have any questions, I can take them now. Okay, if not, that's it for the FakeNet workshop. Thanks.